Mrs. M. Priyadarshini, ME MBA, is doing PhD, is currently working as teaching fellow in the Department of IST, Anna University, Chennai. She completed a Master's in Software Engineering from Anna University. She has about 10 years of experience in handling courses for UG and PG. She was serving as Technical Evangelist for corporate over 4 years in Java Enterprise Technologies, Software Engineering, Databases, OOAD and Design Patterns. She is proficient in handling IT projects as well into concept development for enterprises. She is doing a research in the area of web services security. Her other areas of interest include software engineering, OOAD, databases, enterprise technologies and service-oriented architecture. She holds many journal publications and conference proceedings in her research area.
Welcome to UGC lecture series in Computer Science Java Part 31. So, in this session we are going to discuss about thread class, about runnable interface, methods in threads, various states of a thread and then few sample programs on threads. So, first we will look into what is a thread. So, thread, it is an individual and separate unit of execution that is part of a process. Multiple threads can work together to accomplish a common goal. So, whenever we write any program, so we will have a main method. So, this main method is a thread. So, it is a process. So, now inside your main method you may have n number of sub process that is running. So, all of them are said to be threads. So, threads is nothing but a separate unit of work which is going to achieve a goal. So, for example, we can see video game. So, here we have various threads running at the same point of time. So, one thread for graphics, one thread for user interaction and one thread for networking. So, you can consider that you have an online video game. So, in your online video game, so the player will be using the video in order to have an interface with that. He is trying to play the game and the graphical part is generated using a thread and then the user interaction is going to be done by one thread and then all the other players concurrently trying to access. So, all of them will have various threads in the network. So, each and every thread, all these threads could work together and bring in a particular application to be run. So, you can see here in this video game process, we have one thread which is created for video and one thread which is created for interaction and one thread which is created for networking. So, each and every thread will have some processing logic. So, all of them will not be common and each one will have a logic based on which that particular application will achieve a common goal. So, all these threads will strive together to obtain a common goal. So, why do we go in for thread? So, what is the advantage of having a thread? One is it is easier to program. So, because I am trying to subdivide my entire process into various threads and each thread has a separate processing logic. So, it is easy for me to code each and every logic separately. Next is it can provide better performance. Thread only runs when needed, no polling to decide what to do. It means that we have a good performance when we use thread. When I want to run the thread, I can run it and whenever I want to suspend it for a particular point of time or suspend it till some other thread executes. So, in that case what I can do is I can have a control over my thread. So, that is one of the aspect which gives performance while we use thread and the other one is no polling is decided what to do. So, it means that whenever the processor is running, one particular thread will acquire the processor and then it will try to execute. So, all the threads, so thread will be in form of queue. So, each and every thread will be given an option to use it. It is like scheduling what we have in our OS. So, multiple threads can share the resources, utilize multiple processors if available. So, whenever I use thread, right, multiple threads can share the same set of resources. I can have n number of processes which is accessing the same particular resource. So, for example, I have an object, all of them are going to use the method in the object. So, in that case all the threads could simultaneously concurrently access that particular thread. So, multiple threads could use. So, you would have noticed whenever you go in for your operating system, at the same point of time you can run many applications in the same system. So, in that case I am trying to have multiple threads that will be running in parallel in my particular system. So, you can see there are many processes that are running in our system. When you go in for your taskbar, you can see all the process that is concurrently running. So, each process could be taken as a thread. So, you can utilize multiple processes if available. So, if I have n number of processes, I can make one thread run in one process and another thread run in another process, or else set of threads could run in one process. Whenever the processor is not free, then I can very well go in for other processor. So, in multiple processing environment also your multi-threading your thread is very useful. So, these are all the advantages of why we can use threads. Next we will see what is the disadvantage of using threads. So, multiple threads can lead to deadlock. We will have much discussion on this later on, what is the deadlock and so on. So, overhead of switching between the threads is high. So, whenever I am trying to use the same processor or else you can say same object, so multiple threads accessing the same object. So, in that case when one particular operation is over, if another person can, then only if another person could do a process. So, then there is a dependency between the one particular thread and another particular thread. So, in that case there is a possibility when one thread is not getting the processor, that is it could not access the resource, or whenever multiple persons are trying to access the resource, one may be occupying the resource for a long time and the other could not get a chance to use that particular resource. So, that is one of the disadvantage what we have in threading, and other one is whenever I switch between the threads, I have to store all the resources, my current position of the thread and so on. So, in that case it occupies time as well as space in order to do. This is disadvantage of using your threading. So, now first we will look into how to create a thread. So, we have two methods to create a thread. One is extending your thread class and other one is implementing the runnable interface. So, you can see here in the first method I am extending the thread class. So, you must implement the run method. Thread ends when the run method finishes. You have to call start method in order to make your thread run. So, this thread class is available in java.lang package. So, it is not needed to import any packages in order to use this thread. So, it is by default available. So, now I can create my particular application or my particular process which could extend the thread class. So, it means that I inherit all the properties of the thread class and then I am going to create my application or my process. So, in that case I need to override the method run. So, already there will be a run method in the thread class, I am going to implement that particular method in my particular class. So, this run method will have the logic of my particular process. So, this particular process ends when I explicitly stop it, or when I stop executing my, when I come to the end of my run method, and then if I want to run the thread, what I have to do is I have to call the start method. So, start method will automatically call the run method. So, you can see here we have a sample program, we have a class called output which extends the thread class. So, this class is available in lang package. So, I am having a variable, string variable called to say. So, here this is the constructor of my particular class. So, you can say that this particular class is also a thread. So, since I extend the thread class, this particular program could now act as a thread. So, now I have a public void run method. So, inside the run method you can see there is an infinite loop here for loop, and then I am trying to print that particular string that is assigned to my thread class, where I have assigned this value to the particular variable in my thread class. Here my thread class is output class. So, I have called the sleep method and I have given the time till when my sleep method, it means that till when my thread has to wait. So, in this case you can see that this sleep method I have written directly inside my class. So, it means that I am invoking the sleep method which is my base class method. So, thread class has a method called sleep. So, I am calling the method sleep with a particular time limit. Then I am catching the interrupted exception. So, this exception is raised when your particular run method is being interrupted by any particular process. So, there may be some IO, there may be some memory process which could interrupt my particular run method. So, in that case it will raise an interrupted exception. So, now this is a program which is going to use the threads that I have created. So, you can see you have a main method. So, inside your main method I am creating through 2 threads. So, new output of hello. So, I have a thread which has a string value hello being assigned towards variable, and then I have another thread in which I have assigned a value called there. So, now I start this particular thread. So, I start the first thread and then I start the second thread. So, whenever I call this start, so it means that I am trying to call the run method. So, once the start method is there with the particular small point of time, this will start running. So, when this exactly this thread will start running is depending on the processor, depending on number of threads that has been currently in the queue and so on. So, there are lot of factors which decide upon when my particular thread will have the chance of being run. So, I can invoke the start, even I can invoke my run method. So, my entire thread will not be running unless otherwise I have a time that is allotted to me by the processor. So, if I do not have enough time, so automatically if there is some interruption from any other IO or something, so automatically each and every thread will be given an option to run. So, you can see here main thread is just another thread that happens to start first. So, before my thread starts, my main thread would have been start. So, all the threads that is created inside my main method are child threads of this main thread. So, main thread can end before the others too. So, since it is the main thread, I can make my main thread to end before the other thread ends. So, any thread can spawn more threads. So, it means that I can have one thread and inside that particular thread, I can create more number of threads and do multi-threading. Here you can notice that we have compiled the program and then we have run this program. So, here you can see that both the threads does not have a fair chance. So, first your first thread runs and then your second thread. So, in the meanwhile your second thread is given another chance to get executed. Whenever you run the same program again in the same processor or in a different system. So, for example, I am running this program in the same processor. So, again I am running the same program, I will not get the same sequence of my threads get executed. So, it means that based on the processor, based on the current number of process what you have and based on the number of interrupts or number of operations, other operation other than your thread your system does, all these will decide upon which thread will be given the chance to run. You can notice that this is the other method using which you can create the thread. So, by implementing the runnable interface. So, this is virtually identical to extending the thread class. So, you are going to have a class which extends the runnable interface. So, in runnable interface we have run method. So, which has to be implemented by the class which implements the runnable. You know that whenever I try to implement the interface, all the methods that is available in the interface need to be implemented by the class which implements the particular interface. So, here in your runnable interface we have only one method, that is your run method. So, you must still define the run method. Setting up the threads is slightly different. So, the process how you create your thread is different here. So, you can notice that here till this nothing gets changed, only we have changed that instead of extending thread I have implemented the runnable. So, the same process I am constructing this particular class, whereas now this particular class is not the thread itself. So, it has implemented the runnable, that is it. So, now in your run method we do not have any implementation change till here. So, we have the infinite loop, we have system.out.println, here we have thread.sleep method. You can see that I told you this has not extended the thread. So, I cannot directly use the sleep method because the sleep method is available in the thread class. So, what I have done is I have called the sleep method directly for the thread. So, this will make the current thread in which or else the current run method in which the thread is, and it will make that to sleep for a particular point of time. So, whenever you have a class name and then whenever you have a method, you know that this particular method is a class method, that is it is common for the class and not for the instance. So, it is making a thread to sleep, and then the same way I am catching the interrupted exception. You can see here, whenever I use this particular class which has implemented the runnable interface, here you can see the difference between the code that we have written there. There what we have done is we have created the instance of the thread and then we have directly called the start method, whereas here my class has just implemented the runnable interface. Here my output, I am creating the instance of my class. Here this is not a thread itself. So, now I am trying to create a thread which is going to take this particular object as the parameter. This thread 1 is literally associated with this particular object. So, this particular object has implemented the run method. So, what happens? So, this thread 1 will literally use this particular run method. Similarly, here you can see that there is another thread which is using the out object. So, out to object, whereas this particular object which has implemented the runnable will have this run. So, both of them are having the run method, and then this run method will be literally run from the particular thread instance that we have created. So, now I can just make the particular thread to start. So, whenever I make this particular thread to start, so it means that I am trying to start the object that is passed as parameter while creating this particular thread. So, here your main is bit more complex than your previous case, and everything are identical for the most part. Only the difference is creating an object with a runnable interface, and then I am passing that object as the argument for your thread creation. So, now we will have a short break. We are going to continue. Now, you can see that what is the advantage of using the runnable interface. So, as I told you, there are two methods using which you can create your thread. One is your particular process or your particular application could extend the thread. So, now your process itself becomes a thread, and the run method that you have implemented inside your application or inside your process will be executed on starting the thread. Whereas, the other method is I am going to create an application which implements the runnable interface, and that particular process or application is passed as argument for creation of a thread. So, literally the object's run method which you have implemented will be run while you start the particular thread. Once I create an application or create a process which extends the thread, I cannot bring in the properties or methods of any other classes that I need to bring in later on. So, it means that only one particular set of methods what is available in my current application or current process could be used, provided if I do single inheritance of my thread. Whereas, in case of a runnable, I am just implementing the runnable. So, I am just writing an implementation for the run method, and if I need to bring in some properties and methods of some other class, something else if I like to do, then very well what I can do is I can create a process which inherits a particular class, again that also implements the runnable interface. Or else whenever I create my thread, I can create a thread and then pass another object which is going to implement the runnable interface. So, I can switch between the same thread could switch between various process or various applications. So, remember that you can extend only one class. So, implementing runnable allows class to extend something else. So, whenever I implement this, I can also extend some other class, both are possible. So, now we will see what all the various methods we have in thread which is used to control your thread. One is the start method. So, this start method begins a thread running. So, whenever I call start method of the thread, so my thread is now becoming active. So, I have created the instance of the thread and then I am calling a start method, my thread becomes active, and whenever your thread is given a chance, that will execute the logic of your run. Next is you have wait and notify. So, this is mainly used for synchronization process. So, anyway whenever we do multi-threading, so we will see what is importance of wait and notify method, and even we will see what is notify all and so on. So, these are used to synchronize multiple threads accessing the same resource. Next is stop method. This kills the specific thread. So, normally your stop method will abruptly stop the thread, and this is now deprecated in the latest versions of your JDK. So, normally we never use this stop method and abruptly stop your thread. Next is suspend and resume. So, whenever a particular thread is running and meanwhile I want that particular process to stop till some other process finishes off its work. So, in that case whenever I want to suspend my process for a period of time, but I do not know specifically what is the period of time till when I need to stop that particular process. So, in that case I can suspend it and then I can resume whenever I like to resume that. So, on particular input or on particular process I can make that to resume. There is a possibility that you have suspended your thread and due to some reason you were not able to resume. So, that particular condition is likely to happen in case of your suspend and resume. Infinitely there is a possibility that your thread may not be resumed. So, that is why they have deprecated this option. Next is join method. So, this join method will wait for a specific thread to finish. So, I am calling join method of a particular thread. So, I have two threads. So, thread 1 and thread 2. So, if I am calling join method of thread 1, so in that case it will wait for specific thread to finish. So, it will wait for thread T1 to finish off its work, then only it will allow the other threads to do. So, join will make the current thread in which your join function is applied to occupy the processor once it is given a fair chance. Next is set priority method. So, set priority method is used to set priority to your thread. So, whenever all your threads are in queue, so each thread will be given a chance based on the priority that has been assigned to the thread. So, normally when your system defined threads other than your user defined threads, you have system defined threads called daemon threads. So, when this thread comes, that will be given the first chance. So, it will have a maximum priority because it is system based thread. So, similarly I can, if at all I feel one of my thread process is very important than the other process. So, what I can do is I can set the priority of that particular thread to high. So, in that case that will be given. So, when one thread with low priority and one thread with high priority comes, so your processor will choose the thread with higher priority. So, the minimum value that you can set for your priority is 0. So, that is your min underscore priority. So, this is a constant which is assigned with the value 0, and 10 is the maximum priority that you can assign to a particular thread, and 5 is default. So, whenever you run your thread, if you are not setting any priority, so in that case it will be normal priority. So, next we are going to see few methods that is used for scheduling. So, highest priority thread runs if more than one arbitrary. It means that your highest priority thread has been given chance when there are more number of threads. Next is yield method. So, yield method, current thread gives a processor, so any other of equal priority can run. So, if none of the equal priority, it runs again. So, this yield method, it yields a chance to all the other threads which has the same priority level. If 2 or 3 threads comes into the processor, in that case what happens is, when I call yield method of one particular thread, it yields a chance to other threads with the same priority. If there is no such thread with the same priority level, so then automatically the thread in which your yield method is called will start executing. So, then what I will do is, so if I have 1, 2, 3 threads, so first thread yields means second and third thread will complete its process, then only your first thread will do its process. So, here sleep method, so you can have milliseconds. You can make your thread to sleep. So, after that particular point of time, automatically that particular thread will come to runnable state. So, when given chance, it will go to running. So, you can see various states of thread. So, new, runnable, blocked and dead. So, just created but not started. So, I have created a thread and I am about to call my start method. So, that is a new thread. Next is runnable. Runnable means that I have created, I have started, and now this is the shift between your start and run. Next is blocked. So, created and started, but unable to run because it is waiting for some event to occur. So, it means that I have started it, it is about to run, but whereas meanwhile some other process has come or occupied your processor, so I have to wait. Next is dead state, thread has finished or being stopped. So, you can see here new, on giving start it becomes runnable. So, next it becomes to dead state when I call the stop method or end of run method. This goes to blocked state when I call wait, or there is some other IO request to that particular process, or if I issue suspend. And from blocking to runnable, it will happen only when I give notify. When other thread gives notify, automatically I can go and make my particular option of running it, and then IO completion. After IO completion, I can come to the runnable state, and or else after resume I can come to runnable state. So, these are various states of your thread. So, here you can see a sample program which creates a thread and which utilizes few methods in your thread. So, class job implements runnable. So, I have implemented the runnable interface. So, it means that I have to implement my run method. So, private static thread. So, here I have array of threads. So, it means that I have n number of jobs. So, here n is assigned to be 4. So, I have 4 jobs. So, these jobs are threads. So, here I have a variable called thread ID, which is an integer, and then I am having a constructor which assigns that integer to my thread ID. So, in my run method, just I have given system.out.println my thread ID, whatever I have set I am trying to print. So, in my main you can see that I am having an for loop which starts from 0 to jobs.length. So, it means that 4 jobs we have. Job of I is equal to new thread, that is new job of I. So, it means that now 4 thread instances will be created by passing this object which has implemented the runnable interface. So, this run method. So, 4 threads with this run method is being created and then started. So, once I start, so the processor in the queue corresponding to the processor will be filled with all the 4 threads. So, whichever is having based on the priority, whichever is having highest priority, here we have not set any priority. So, all of them will have 5. So, all of them will be given the chance to get executed. So, now at that point of time processor will decide which job to run first. And then now I have a try block where I have a for loop which is going to call the join of all the 4 jobs. So, now whenever I say first job dot join, so in that case it means that this particular job has to run, then only the other job has to run. So, this will complete its work and then the next thread can start. So, when processor allows job number 3, so then after completion of 3 the other jobs will run. So, 2, 1 and so on. Similarly, so this also depends on how your processor gives the chance to that particular jobs. So, each and every time when I run the program, based on which particular thread is given the chance, that will get executed. So, you can see here we have compiled it and we are trying to run. So, first time your 0th thread, that is your first thread, is given a chance, and once your first thread has printed it, then your 3rd thread, and meanwhile your 2nd thread and 1st thread. So, similarly, when I try to run the same job in the same processor, but here 0, 3, 1 and 2. So, here 0, 3, 1 and 2. So, it means that based on here 3, 2 and 1, here 3, 1 and 2. So, based on which particular job or which particular, here it is thread, right, which particular thread is given the chance by the processor, if it has sequence of activities also, it will finish off, then only it will come to the other job, since we have issued the join method. So, now as a summary, we have seen what is a thread class and what is a runnable interface. So, what is the advantage of going in for runnable interface, and what are all the various methods that we have in thread, and then we also have discussed about various states of thread, and also we have seen sample programs using those methods of threads. So, from this session you will be able to answer questions such as give the 2 ways to create a thread, write a sample program and demonstrate various states of thread, list down various methods in thread class, and also you can give the significance of the run method. we come to the end of the session where we have discussed about the thread, and we are going to see in your forthcoming session about multi-threading. Thank you.